This time in Fundamental Skills for Math 084, we're going to talk about solving a system of equations using substitution. So here's the sort of situation this applies to. We have a system of two linear equations, and we're going to solve it using substitution. Incidentally, one reason why you would want to use substitution for this particular system is because one of the two equations, the second one here, it seems like it would be easy to solve this equation for one of the two variables. The second equation is going to be very easy to solve for x, because x is already almost isolated. And that's what makes substitution work. So let's take this equation and solve it for x. We can do that by multiplying both sides of this equation by -1. That turns this equation into x equals negative 3y plus 13. Okay. Now the idea behind substitution is this equation is telling us what x is in terms of y. And since we know what x is, we can take this and put it into the other equation. That gives us minus, and then the stuff we got for x, negative 3y plus 13. And then the rest of the first equation, plus 2y equals 2. Now this equation that we've obtained by substituting the second equation into the first, notice there aren't any x's. That means we can solve this equation for y, and then we'll know what y is. So let's start by distributing this minus sign. We get 3y minus 13 plus 2y equals 2. Now we can combine all these y's. We get 5y minus 13 equals 2. And then add 13 to both sides. We get 5y equals 15. And then divide both sides by 5, and that means y is 3. All right, so now we know the value of y, but remember that solving a system of equations means that we need to find the value for y and the value for x. To find the value for x, we'll look back at this equation that we started with initially, x equals minus 3y plus 13. This can tell us what x is. All it needs is a y value. Well, now that we know the y value we want, we can put that into this equation. So we get x equals minus 3 times y, which we now know is 3, plus 13. And then just do this arithmetic. Negative 3 times 3 is negative 9, plus 13 is 4. All right, so that means the point that is our solution to this system of equations is the point 4, 3. Okay, and so we're all done. If we wanted to check that this solution really did work, we could take this x value 4, this y value 3, and put them into both of the original equations just to check that they really do work. When you're solving a system of equations, a system of linear equations, there are three possible things that can happen for your solution. One is what happened in this example. You get exactly one solution. But there are a couple other situations that can happen, so let's see examples where those things do happen. Here's another system of linear equations, and it looks like using substitution would be a good idea because this second equation is already solved for y. So we can proceed immediately to substituting without having to do anything else first. So we can take negative 2/3 x plus 1 and put it into the first equation for y. We get 2x plus 3 times y, which is negative 2/3 x plus 1 equals 4. And this equation doesn't have any x's in it, so we can, it doesn't have any y's in it, so we can go ahead and solve this equation for x. So we'll start by distributing this 3 here. We get 2x plus negative 2/3 times 3 is negative 2 times x. So 3 times negative 2/3 x is negative 2x, plus 3 times 1 is 3, equals 4. And then the x's cancel, and we get 3 equals 4. Now remember what we were expecting to get from this equation. We were expecting to find an x value that would make the system work. Since we get this equation, 3 equals 4, this is describing the x values that will work. Of course, this equation is always false. What this means is there are no x values that will work. And that means there are no solutions to this equation. It is impossible to find an x value and a y value that will make this system of equations work. Okay, so this system has no solutions. So it's possible to get exactly one solution, like with our first example. It's possible to get no solutions, like this second example. Let's look at a third possibility. So here's another system of equations. One of these two equations has already been solved for one of the variables. This first equation is already solved for x, so we can take what it gives us for x and throw it into the other equation and see what happens. We get 4 times x, which is 1/2 y plus 4, equals 2y plus 16. And remember, since this equation doesn't have any x's in it, we're expecting this equation to tell us what y should be. So this equation is describing the y values that will work. So let's solve this equation to find the y values that will work. So we'll start by distributing this 4. We get 4 times 1/2 is 2, so 2y plus 4 times 4 is 16, equals 2y plus 16. And now we can, to solve this sort of equation, we need to get all the y's to one side. So let's subtract 2y from both sides. And we get 16 equals 16. This is, again, kind of strange, like the last one. All of the variables are gone. But remember what we were expecting this to tell us. We're expecting this equation to describe the y values that will work. Since this equation is always true, that means any y value will work. So any y works. This means that there are infinitely many solutions to this system of equations. Any y value will work, and the x value that goes with any particular y is just given by one of these equations. So if you wanted to know what x goes with y, any particular y, you could plug a y value in here. So this line, right, the graph of this equation would look like a line. The points along this line are all solutions to this system of equations. That's why this system of equations has infinitely many solutions. In fact, you remember that a system of equations gives you a solution because it's the solution is the intersection point of the two lines. Well, these two equations, each of them is a line, they're actually the same line. So that's why this system of equations is giving us infinitely many solutions. It turns out those are the only 3 possibilities if you have a system of 2 linear equations. Either there's infinitely many solutions, like this last example, no solutions, like our second example, or exactly one solution. By far the most common situation is to get exactly one solution.